On June 30th, 1908, a blinding, massive object streaked across the remote Siberian sky at an unbelievable speed. Hundreds of miles away, the resulting shockwave threw people to the ground. It shattered windows, flattened structures, and caused the night sky to glow so brightly that residents across Europe could read at midnight. The blast released enough kinetic energy to flatten an estimated 80 million trees in an instant. This single detonation packed the destructive force of a massive thermonuclear weapon, occurring decades before the technology even existed. When that much kinetic energy violently meets the Earth, physics dictates a very specific consequence. A strike of that magnitude leaves a massive, unmistakable scar carved deep into the planet's crust. Siberia's extreme isolation, brutal weather conditions, and years of Russian political turmoil meant official scientific expeditions couldn't safely reach the epicenter for nearly 2 decades. When investigators finally hacked their way through the frozen wilderness to ground zero, they fully expected to find a colossal asteroid resting at the bottom of a giant gouge in the Earth. What they actually found broke all scientific expectations. The ground was completely intact. There was no crater and no fragmented space rock anywhere to be found. The weapon that leveled the forest had vanished, creating a vacuum of evidence that remains a staggering scientific anomaly. Across hundreds of square miles, millions of charred trees lay flat in a mathematically perfect radial pattern, all pointing away from a single central point. But right at the dead center of this devastation was a glaring anomaly. The trees at the epicenter hadn't fallen at all. They remained perfectly upright, entirely stripped of their branches and bark. The combination of these bizarre blast patterns with the total lack of a crater sent researchers scrambling. For years, the standard laws of physical impact failed to fit the evidence found in the Siberian soil. Darker, fringe theories eventually emerged to fill the void. Speculation ran from detonating alien spacecraft to microscopic black holes tearing through the atmosphere, or even pockets of antimatter colliding with Earth. While those ideas sound entirely absurd today, they highlight how deeply human logic struggles when confronted with an apocalyptic event that leaves no physical cause. Modern science now suggests the object never hit the ground because the Earth's atmosphere itself acted as a massive, violent detonator. This diagram illustrates an atmospheric airburst. When a space rock enters at extreme speeds, the dense air creates massive friction, causing pressure to build up exponentially against the object's leading edge. Eventually, that intense pressure differential hits a critical breaking point. The meteor effectively crushes itself against the air, disintegrating in a fraction of a second and instantly releasing all its kinetic energy. That energy forms a spherical shockwave moving rapidly downward. When that wave slams into the ground, it rushes outward, flattening the surrounding trees horizontally, while the vertical force at the center leaves trees standing bare. The absence of a crater is the physical signature of a space rock converting entirely into kinetic energy before it ever touches the ground. Tunguska represents a recurring statistical warning shot fired directly from our own solar system. If an identical airburst were to detonate today over a major metropolitan city, millions of people would be vaporized instantly with absolutely zero warning. This persistent vulnerability is exactly why modern astronomy dedicates massive global resources, like this high-tech observatory, toward carefully mapping and tracking near-Earth objects. While our tracking technology has drastically improved, we still have a blind spot. Objects approaching from the direction of the sun can easily blind our instruments, leaving us exposed to a surprise impact. The 1908 blast proved that our planet remains firmly in the cosmic crosshairs. We have to worry about the rocks large enough to hit the ground, but we also have to watch out for the ones that turn the sky itself into a weapon.